This video will demonstrate how to perform operating performance checks on the MOHR CT100B Series TDR. Let's get started. Always remember to properly discharge static before connecting to any high-frequency test equipment, and never connect to live equipment. The CT100B operating performance checks are a series of procedures used to verify the calibration of a CT100B TDR. Operator performance checks should not be considered calibration. If a unit fails any operator performance check, it should be serviced by a qualified repair facility. This series of checks should be performed after a unit has been newly calibrated to verify compliance to published specs, but may also be performed to determine if calibration is required. It is recommended to perform these checks at least every 6 months. Contact us for more info on calibration. These steps are designed to allow a CT100B operator to verify the properties of an individual unit to each published spec. Any references made to the CT100B should be considered applicable to the CT100HF and CT100S. A couple of things to note: operator performance checks should not be considered calibration. If a unit fails any operator performance check, it should be serviced by a qualified repair facility. Operating performance checks are a series of tests compared with specs outlined in Appendix A with the procedures described in Appendix B of the MOHR CT100B Operator's Manual. This video will split these tasks into 3 main categories: output, vertical, and horizontal, as well as show what measurements are done simultaneously. To perform these tests, you're going to need some required equipment: a MOHR Precision 50 ohm Terminator, a MOHR connector SMA female to BNC male, a MOHR 50 ohm 36-inch reference cable, and a MOHR shorting cap. For the CT100HF and CT100B with SMA option, you will need a MOHR Precision 50 ohm Terminator, a MOHR connector SMA male to BNC female, a MOHR shorting cap, and of course a MOHR 50 ohm 36-inch reference cable. Additionally, a device capable of taking accurate pulse measurements with documented calibration will be required, and if working with a CT100B BNC, an open terminator will be needed. Coaxial adapters with low TDR reflections of less than 5 ohms are required in cases where adapters are used. Getting ready for our test, we're going to disconnect any cables from the front BNC or SMA connector and connect the instrument to the external 24-volt power supply and connect to a standard 3-prong AC source. Allow the unit to warm up till it displays a steady temperature. To display the temperature, press the menu button, select Settings, followed by Display, then Temperature. The temperature will display in the upper left corner of the screen, just under the battery icon. We need to verify our calibrated 50 ohm terminator by connecting our volt ohm meter, and we can see that this one is 49.9 ohms and well within tolerance. Getting into output checks, let's start with output impedance check. Position a cursor before the falling edge of the trace. We have it highlighted here. Now place a second cursor well beyond the falling edge. Now attach your 50 ohm terminator to the CT100B. What I have highlighted is the reading of 49.9 ohms that matches our measurement earlier, and the delta of negative 0.8, which is the difference in ohms between the two cursors and is a measure of the deviation of output impedance from 50 ohms. For jitter, noise, and rise time sampling efficiency checks, going to connect a 50 ohm terminator to the CT100B's front panel cable connector. Select Menu, Settings, and Diagnostics menu to enter the Diagnostics submenu. Select Jitter. Verify you have the 50 ohm connector attached to the front port and press OK. After a moment, the window appears with a list of measurements. The value for jitter used in the specification for a CT100B is jitter peak to peak. The value for noise is noise peak to peak. The value for 20 to 80% and 10 to 90% reflected rise times are both displayed as 20 to 80 rise and 10 to 90 rise, respectively, and can be compared with Appendix A specifications in the MOHR CT100B operator manual. For the pulse amplitude check, pulse width check, pulse repetition period check, pulse frequency check, and sequential sampling rate check, these measurements will be done simultaneously. These measurements should be taken with a device that can accurately display frequency, pulse width period, and amplitude. Be sure to set the device input impedance to 50 ohms or you may not get the correct measurement and could damage the CT100B. Connect one end of the 36-inch reference cable to the capable pulse measurement device and the other end of the 36-inch reference cable to the CT100B's front panel cable connector. A trace should appear on the screen, and switch the CT100B into the short pulse setting in the main menu cable length setting. This test will also need to be repeated for medium and long cable lengths. And here's a screen capture of the results window. For the pulse amplitude check, it should be between 290 millivolts and 310 millivolts. For the pulse width check, pulse should be between 1 and 2 microseconds for short, 5 to 6 microseconds for medium, and 20 to 21 microseconds for long. For the pulse repetition period check, the average pulse repetition rate should be about 4 microseconds for short, 20 microseconds for medium, and 80 microseconds for long. For the pulse frequency check, frequency should be 250 kilohertz for short, 50 kilohertz for medium, and 12.5 kilohertz for long. For the sequential sampling rate, should be the reciprocal of the pulse repetition time. For our vertical scale check, I'm going to twist the vertical scale knob clockwise. The vertical scale should drop to 0.5 millirho per division, and the trace should expand accordingly. For vertical accuracy check, vertical accuracy is checked by comparing the CT100B's impedance measurements against a load of known impedance. The supplied 50-ohm terminator is required for this. Connect the 50-ohm terminator to the front panel connector, and move the cursor out to a length greater than 300 nanoseconds. Impedance of the cursor should be between 45 and 55 ohms. Vertical accuracy should be checked for short, medium, and long cable lengths. The vertical accuracy check. Attach an open to the CT100B. And position a cursor on the trace so that it's well after the open. The vertical measurement should be between 940 millirho and 1060 millirho. For vertical position check, increase the vertical scale to 500 per division by turning the vertical scale knob counterclockwise. Use the vertical position knob to move the live trace completely above the horizontal midline of the screen, and then use the vertical position knob to move the live trace completely below the horizontal midline of the screen. For ohm readout range check, connect a 36-inch reference cable to the CT100B. Position a cursor on the trace well beyond the end of the cable. The vertical impedance measurement should read greater than or equal to 1500 ohms. Position a cursor on the trace well before the leading edge of the pulse. The vertical impedance measurement should read less than or equal to 1 ohm. For the resolution check, position a cursor at a point on the trace where vertical impedance is greater than 1 ohm and less than 1500 ohms. And the CT100B should display 3 digits for this measurement. Now for horizontal checks, starting things off with the cursor readout range check. First, going to verify that the VP is set to 1 using the M function. We need to turn on extra long mode by pressing Menu, select Measurement, and toggle extra long mode to on, and select OK to confirm. Turn the horizontal scale knob counterclockwise until the horizontal scale is maximized. With the horizontal position knob, move the cursor to the most far right position as possible. The absolute distance measurement for the cursor is the upper limit for the cursor readout range. This number should be larger than 10,000 meters or 33,000 feet. Now we're going to position a cursor at the far left position. The absolute distance measurement for the cursor is the lower limit for the cursor readout range. This number should be less than -1 foot or -0.3 meters. For the horizontal range check, the horizontal range and cursor readout range are always equal. As for the horizontal position check, this test is passed implicitly when the cursor readout range and horizontal range checks are passed. For the cursor readout resolution check, I'm going to use the horizontal scale knob to set the horizontal scale to 0.00330 feet or 0.001 meters per division. Position a cursor on the screen and note the absolute distance measurement for the cursor. Move the cursor the smallest possible step using the horizontal position knob. The difference between the new measurement and the previous measurement is the minimum cursor readout resolution. The distance cursor resolution check. Cursor readout resolution is a value determined by a constant. It can be measured by counting distinct locations that a cursor may occupy between two division lines, including one of the division lines. For the distance measurement accuracy check, in a previous video, I measured this cable to be 34.75 inches and having a VP of 0.704. We will do that test again and compare the results. Accuracy is determined by taking a cable of known length and velocity and comparing the known values against measured values. Accuracy is reported as a percentage when determining accuracy. This is to ensure that horizontal calibration has been performed accurately, and accuracy should be checked for short, medium, and long settings. For the horizontal scale check, from the main menu, set cable length to long. Using the M function and M function knob, set the VP to 1. Turn the horizontal scale knob counterclockwise. The horizontal scale should increase beyond 61 meters per division or 200 feet per division, and the tray should respond accordingly. Now turn the horizontal scale knob clockwise. Horizontal scale should decrease below 0.01 meters per division or 0.03 feet per division, and the tray should respond accordingly. And there you have it, operating performance check for the MOHR CT100B Series TDR. Check out our website at mohrtm.com for more info, and contact us directly if your device needs calibration. Be sure to subscribe to our YouTube channel for more updates, and we'll see you next time.